All right, so hop into things here today. We'll start out kind of today. Kind of revisiting and talking a little bit about the idea of kind of sports betting. Look at a couple academic papers and really try to break down kind of what they did with the regression results, interpretations. I'm going to be expecting you to do a little bit more of that on the final. So knowing how to look at a very basic regression and interpret these different coefficients. Okay? We'll also talk a little bit about making predictions with those, but primarily kind of the interpretation. So we talked about this idea that when, sports books are setting lines, they want them to be 50-50 so that they're kind of guaranteeing that no matter what the outcome is, they'll hopefully, have made just as much money as they lose. Now, I kind of simplified this last class, and I think I got a question after class that I went over this, but I'll do a little bit better job today. So let's say I've got this betting line set, and we said that really what we're wanting our expected payout to be as a company is zero. If we exclude the amount that we're taking off the top, we want the remaining, payout, the odds that we're paying out, we want that to be a break even. Right? So this would be the idea we had. Okay, what's the probability? For instance, let's say the probability that, I don't know, the total, whatever points total I have for the game, that it goes over, right? I'm going to multiply that by, well, what am I paying out if that occurs? Well, we said they don't pay out, I don't even know the exact numbers. I think it's like 194 or something. But if they're not going to pay out, like it's the idea of a raffle, if we all put $1 in, and then, if that's right, like that would be split amongst everybody. Well, that's kind of the idea of what these sportsbooks are doing, but they're keeping a little bit of that total pot, right? So they're not going to pay out for every person that bet one way, there'd be someone the other. So instead of you bet $1, you get $2, you get a little bit less, right? However, they want to make sure that this amount is the same as, you think about kind of these people, they're going to lose $1, right? I'm sorry, I shouldn't have, I've got this backwards now. So let's say, these are like the people who are kind of voting the under, right? So they're losing out on $1, right? Oh, what do I want to have? This isn't what I want to do. But so I broke this down kind of more like a dollar amount. This isn't actually what we want, right? Because that's one individual consumer. So when we're thinking about wanting the expected payout to be zero, I was just kind of setting that up idea last class. More accurately, what we want to do is say, look, I know that I don't just want the bet to be a 50-50 bet. The reason why I want it to be a 50, I'm trying to get 50% of the money on both sides, right? So this was the idea if we're thinking about like an individual's decision, kind of betting with their single dollar. But me as a company, if people fall victim to some of these behavioral issues and bet isn't rational, right? I want to make sure that if the over occurs, right, the probability that the over occurs times the total amount of money that has been bet on the over. Well, that's going to vary, right? Not everybody puts in the $1 bet, right? We're using that as kind of a base example. So some people put in more money on a bet, and so we can't just take the number of people. It's the number of people, not times the. It'd be like the number of people times the average amount bet, right? Which is just going to be the total amount of money that was bet on the game to go over this point total. We would then say, okay, if instead the under occurs, right? And we've got a certain percent of the money that came in on the under, we want to make sure whichever of these occurs, one of these is going to be positive, one is going to be negative, right? And so let's just assume this is the one that's kind of negative here, right? We want to try to make sure that this expected payout is zero. But we won't just be using kind of the amount of one bet, it's going to be the total amount of money put on both sides. Okay? So what starts happening, right? And remember, they're setting these, or in a way, they're kind of setting, what they think that probability is. So let's say day one, I don't know, it's the Super Bowl, and they set the point total. They think it's going to go over 40 points, right? If people just like to watch games and they think teams are always going to score more than they do, and we start seeing a bunch of money get put on the over, right? Well, what's going to happen if we have this 50-50 bet initially set, right? Our initial line was we believe there's a 50% chance it goes over 40 points, 50% chance it goes under. But then people start over betting on that it's going to go over. Well, now, if these probabilities were both 0.5, and I have a higher amount of money on the over, what happens if the over hits? Yeah, I'm going to have a larger negative value than positive value. I'm going to lose money as that sports book. So what can I influence? I can't necessarily influence how people are betting, with the exception of I can start to move these lines, right? So I believe that the probability over hits is still 50-50. What we're actually thinking about in terms of the expected payoff, initially, it'll be the probability that I, 50-50, that I'm setting this line to be 50-50. But if people start betting more on one side, what am I going to do? I'm going to start kind of lowering the probability that over hits, or start raising what that total over line is going to be, right? So they're constant, we start out in the scenario where it is that the exact probability is 50-50. But from there, if we see more money go on one side, we have to start adjusting kind of what that overline would be, so that it's going to actually be less than a 50% chance it occurs, right? If this number gets really, really high, I want the percent chance that the over hits to be not 50-50, but something like, maybe even 40-60, right? So if you can identify these betting behaviors, the original line is still what they would predict to be 50-50. But if betting behavior makes them start raising the line, well, then you can actually put some bets in that are more than a 50% chance likelihood to occur. So in this case, in this example, if more people are betting on this over, right, so that they're going to have to start increasing what that point total is, and that this is pretty consistent across games, what would make sense to do is not, and you think that, the unders don't bet day one, bet right up into the game starts, right? Because that line, they're going to have to move it to account for betting behavior. If you believe the sports books, you think they're good at what they're doing, I can tell you, you've got a lot of really smart people working for them, and their initial lines are usually very accurate, right? The betting behavior of the public is what then starts to influence these lines, right? Point totals, point spreads, so that if you bet further from the initial start date, you actually can get some bets that might have like a more than 50% chance of occurring. Now, that means that you have identified like a consistent, systematic betting behavior, error by the public, but generally that's a kind of a nice way. So a lot of times what you'll see people do, or what you could do, is look at what the movement of the line is to kind of tell you whether or not that's a better bet, right? If you see that the line is moved way, way up for the over, that probably tells you, well, now at this new line, taking the under is probably going to be more than a 50% chance, right? It might be something even as high as like 60%. And this also is going to depend more on things that there's a lot of money bet on, right? If you're looking at some Division III game, even if 100% of the money's on the over, I don't have to adjust it near as much as if that, because that might only be what, I don't know, a couple $1,000. Where if I'm looking at the Super Bowl, well, man, the amount of money bet on that, I could see the imbalance get really, really huge, especially if those lines are put out early and there's a lot of time to adjust. Okay? But it really is just in terms of we're trying to get that expected payout to be zero. And it's not quite technically the expected payout from the bets. Remember, they're always keeping some lump sum amount, right? They're skimming it kind of off the top. Right? So what's one thing I haven't accounted for here? If I set, say, a point total of 40, and that's the over under, what could happen? Number of points scored in the game is exactly 40. So what happens there? Everybody gets their money back. Why does that not really influence the decision of the sports book? So the probability of this push, that's exactly the number I hit, right? The amount of money that was bet, right? Everything just goes evenly back, right? It's zero, right? That's influencing, I'm paying back exactly what I was given. That's not changing my expected payout, right? So really, all we have to be concerned with is just that we kind of balance out the money that's on the over versus the money that's on the under. Now, initially, we try to do that by setting a 50-50 line. If we start to see that not 50% of the money is on either side, we start to move the line so we can kind of try to guarantee that.
Questions on that idea?
Yeah.
What about like reverse line movement?
So if it went
Like where,
down,
yeah, where like more like the public is on one side, but it goes the other way. Like the line moves down.
so you're saying, here we'll go, come up with an example here. So let's say I'm playing the Super Bowl, right? And whatever team I'm looking at, let's say the point spread is, I don't know, -7. Right? I think this team's going to win by 7 or more. Right? So you're saying more people. So I either think that I think about point total is going to be over -7, not point total, sorry. The point spread is going to be over this, or it's going to be under this, right? So more people start putting money that they're going to win by 7 or more. What you should see the line, and you're saying the line is going to go to like -10.
No, like if more people bet over or like
that it's going to cover this. Yeah, you can talk. Yeah,
then it goes down.
so that's what it
Goes
should do.
reverse.
So it'd be the exact opposite of what we were just saying. So let's think about here's that the team. Here's a mathematical way of writing it. That they win by this is really what a line of -7 is saying, right? That they're going to win by more than or win by 7 points. So the opposite of that is, well, what's the probability that they win by less than 7, or that would also include losing, right? So initially we want to set that as a 50-50 bet. So this would be the amount of money on that they win by more than 7 points. This is the amount of money if they win by, or sorry, the amount of money on that they win by under or less than 7 points. If people start betting a lot more that this point spread is covered, well, then I need to make sure that this is the same or the equivalent of this. So what do I start doing? Here it's like the directional arrows down, but it's that I start moving this down, right? So if it's -7, I actually have to move it to something like 10, right? Or -10 would be greater than or equal to 10. If you ever saw it work the opposite direction, I don't know what the sports book's thinking, right? Because they're just making it even worse. Maybe like, I guess the only story there would be if all the money's coming in one side and they're like, well, you could take a really big gamble here and hope that the other side hits, then maybe they would move it in the opposite direction. But it doesn't really make any economic rational sense. But yeah, that's why you see those lines move. And it gets a little bit trickier when you're talking about, there's got to be a better way of displaying this, right? Because -7, it's actually, you're winning by more than, or more than 7 points. So the line moving down is actually becoming a larger negative value. Is that kind of what you were getting at?
Yeah, I was talking about the weird scenario.
Yeah, I mean,
Because I'm pretty sure that like happens. I've seen that happen before too.
so you've looked at the percent of money. So it's not just the percent of bets. That's the one thing so it's percent of money. If it starts to go too much on one side, I mean, the only reason why the sports books would do that is if they've got also new information that they believe that, yeah, maybe more of the money is on this side, but what we previously thought was a 50-50 bet, something has changed or new information has come out that we now believe, oh yeah, not only should we increase this to like 10 negative, like maybe it's like we should put this to -10 because a lot of money's coming in this, but we just got some information that like our original line was not right. And so that our original line should have started out at -3, which then means those would kind of counterweight each other. So that's my guess. If you ever see that play out in practice, it's not a result of the money coming on one side. It could be the result of more money came in on one side because there were, and usually it's not the general public, it's like these people like involved in whatever sports industry who have this new information that the sports books didn't originally have, right? But that's what it would explain if that ever worked in the opposite direction. It would have to be some type of new information that wasn't baked in to the original line.
Any other questions? I don't know. I just think this is kind of interesting to kind of talk through these things, but it really is like pretty fundamental in terms of like the general kind of trends that we see. Let's go to this paper that I put up on, Canvas. So let's do the sports betting volume since we're yeah, we'll do this one first. So there's a couple different papers out there. So this will be the first one to look at. So this is kind of this was called, what did I call it? Sports betting volume. And it's just up on Canvas. I just put it under the files tab. So they've got, this is a nice paper. They kind of write out what their regression is for us, right? So what they're kind of interested in is, okay, we just kind of talked about betting behavior by the general public can influence the lines, right? If too many people or too much money is getting put on one side, you'll start to see those lines adjust. So if I was trying to make money, what I might want to do is, well, what are the things that are causing people to incorrectly kind of bet on one side, right? So we've got kind of all these different variables. So you've got, was it a road favorite? So just a one if the team was a road favorite or not, the point spread of the game. Kind of talked about this a little bit more class. They allowed that relationship to be quadratic. They include all these other control variables, right? Even the TV network it was on, day of the week, for whatever reason, if on Thursdays people think that, the home team's always going to have an advantage or something like that. And so the betting volume is just the total amount of money bet on that specific game. Okay? So which of these variables are influencing that the most? So we'll come down here, look at their results. So they kind of broke this down in different categories. We'll just primarily kind of focus on this first one. It tells us most of the story. So if we look, did they not put their R squared in there? Oh, okay. They should have put their R squared in there. I was going to take a look at that first. But if we're looking at things, we start to see some things pop up as significant, right? So remember, all these different betting lines, hopefully initially, at least initially, they've been set as a 50-50 bet, right? So all of these things should already be factored in to what those lines are and shouldn't have an influence. But some of these things are, right? So if we look at whether or not the team was a road favorite, we see that for whatever reason, the general public likes to put in a lot more money on people who are road favorites, right? We also see that there's some quadratic relationship to point spread. So here, not to get too in the weeds, right? But we've got a positive sign on our first kind of linear value and then a negative sign. So this means that there's an increasing relationship between the point spread and how much is being put in that game, right? However, it's increasing at a decreasing rate, right? So we can kind of think about there. What I'm looking at is, if I want to know how is this X variable, which is the point spread, remember, point spreads, the larger they get, that means the more lopsided a game they believe this is going to be. And then kind of this was the total volume of bets, right? So as that point spread gets wider, right, you have people thinking this is more likely the game is going to, be a blowout, and they might be more likely, even though that point spread is larger, they're still more likely to put money on that, right? And so we actually see this increasing relationship, but then it starts doing so at a decreasing rate, right? And it could even be that at some point we start to see the volume of bets starts to even decrease as that line gets higher, right? So this would be the idea that if I'm moving from a point spread of, I think the team's going to win by 1 point, at least 2, at least 3, we start seeing more money come in on this team. But once we get to like, I don't know, -14 for an NFL game, well, then people start to think, yeah, it's way, way less likely that you're actually, now, these have already been factored into the betting line. This is all just behavior that's not consistent with, these have already been set as a 50-50 line. So if we look at that, we could probably estimate, okay, well, what point spreads are people betting more on or less on either side? We also have the sum of the win percentage. So here, this is kind of an interesting one, that people just bet more on a game when the two teams are of higher quality. So if you look at the sum of the win percentages, here we've got a positive impact, right? So it's increasing just the amount of money that's bet on that game. Right? You could also then go down further. If the game is on network television, or Christmas Day even has a huge positive effect, right? You see ESPN, ABC, TNT, those games we would predict a higher on average kind of value of bets in those games, which would lend to the hypothesis of what, so we talked a little bit in last class, what might be occurring if people who are sports, who are betting on the sport game, what might they be more likely to do? Watch the game. So if we're thinking about these games in prime time, or we're thinking about these games that have more value, like a game on play at Christmas, well, we're going to see more people are watching, more people want to increase their utility. So not only will they watch, they'll also bet on that game, right? So this is because this is strictly our dependent variable is the value of bets, right? Or the amount of money. What's kind of interesting, we also then see if it's on ESPN too, right? And this wasn't NFL, so I was using NFL in my point spread example, but I believe it was the NHL and NBA here. So if they ever end up on ESPN2, probably it's because, wasn't as likely a game people wanted to watch, and we see less amount of money bet on those games. Right? So people don't like to bet on things. This would suggest that they can't watch the outcome, right? I don't like to bet on something if I'm not going to be able to watch it, right? Let's see. This is a little surprising to me, NHL, NBA, that really the group we left out here the group we left out was Wednesday. So every other day has a positive kind of additional amount bet. So that would tell us like Wednesdays are the least bet day. It kind of makes sense. I don't know, middle of the week, probably more things going on as opposed to like a Friday or on the weekend or even early in the week. So that's just, no reason to believe that going into it, but it's kind of interesting that that's the least kind of traffic day for betting. And then we go down here. I believe it's a pretty similar kind of story for NHL games, right? Although some of the significance is lost. So it looks like for NHL betting, maybe it doesn't fall victim to these things near as much as NBA betting. Right? So we could do this for any sport, right? Just to see, okay, what is the effect of all these different things on how much is bet in this game? Oh, here's their R squared. So like NHL, they get what? 0.17. So they're explaining like 17% of the variation. NBA, they can explain much more of the variation, which might be one of the reasons why that NHL results, we don't see as much significance, right? There's still a lot of other things that are explaining the variation in betting behavior in the NHL than in the NBA, right? That higher R squared tells us our control variables, all those right-hand side variables that we can see these coefficients of, they explained almost 50% of the variation in how much was bet in the game. Well, as for the NHL, we tried to include all those same additional control variables, and we can only account for about 17% of the variation. So there's a lot more that we can't explain, okay? I think that's the last table from this one I want to go right on. Any questions kind of over that idea? So if I can identify the things that make people more likely to bet in the game, things like the odds should be 50-50. I can start to figure out what bets the public is going to overbet or underbet on. We'll then kind of go to the next one because I think this is kind of interesting as well. And it kind of highlights this inconsistency or irregularities in the public's betting behavior versus kind of what these sports books and these betting lines are set at. So the second one is COVID and gambling. That's what I called it, right? But they exploit this idea of COVID. So let me go down here. Wait, did I label this incorrectly? I think I did. This isn't the one I wanted. Hold on. I might have, which one did I have here? So I had COVID and gambling. Let me look at the downloads. I might have saved the wrong file. Yep, I definitely did. Hold on. Well, this will be good for a project. Must have saved it on the wrong name. So let's do COVID and gambling economics. I know there's a paper out there I want to find. And let's see. believe it's this guy right here. Hopefully. Let's see if this is the one I wanted. No, this isn't it. Oh, I just found it the other day. Oh, I know why. I want COVID and sport gambling. No, I think I should find it. So overview, bans, measuring the economic impact. I think this is it. This is a synopsis of it. Oh, come on. I know it was soccer. Sports management. Oh, maybe we'll do something different. Like, oh, I can't find this. So soccer gambling. COVID. Interrupted behavior. Here it is. I think. I'm hoping because it's a pretty interesting paper. Nope, that's not it either. Let's try this one more. This one looks like impact of gambling. No. Wisdom of crowds. If this isn't it, then I'll just do something different. I think it's trying to pull it up. This is it. All right. I was gonna say, I know that I had it the other day. All right, let's download this real quick. And I'll put this one up on Canvas after class. Yes, I want to replace it. Come down here. All right. It's gonna be a little bit easier to see. If I pull it up in this PDF here. So down here. Is this not the one that I just looked at? Okay, well, we'll just look at it on here then. So here's I don't know why that's not downloading and saving for me. So this is basically the regression that they run. So their Y variable is going to be whether or not a team won or not. And they're just looking at bets on money lines for games, right? So what they did was they used, right, this win probability that the sports books came up with, right? So they're controlling for what that line should be, right? Or they're controlling for, this is the best guess or the best estimate of what we have should be the probability that this team wins. So they were just looking at these money lines from the sports betting companies. You know, if it was, negative 800 or something, much more likely that team's going to win. They were using those probabilities to project whether or not this team was going to win. Okay. This Y variable was, did the team win or not? Right? So they're controlling for all the factors that were built into coming up with that probability of winning the sports books calculator. So we should be controlling for all these other factors, or at least we're controlling for how the sports book believes that they're going to impact the probability of winning. So for instance, if I'm thinking about my Y variable is just, will the team win or not? Right? Or I'm trying to come up with, to be a little more complicated, I want to know what the probability the team wins are. Right? Well, I should have, if I have run some regressions, I can get the effect, that coefficient that every single one of these control variables would have on the probability of winning. For instance, if I just ran the regression where I had this 1-0 variable, and let's say I do something real basic where I do, were they the home team or not? Well, once I have a value here, I don't know, maybe it's 0.05, this would tell me, okay, if the team in question is the home team, the predicted increase in their win probability is 0.05, right? So when I'm trying to come up with a predicted probability that they win, I'm taking into consideration every single coefficient on every single variable. Right? That's what the sportsbook are doing to come up with this prediction for what's the probability they actually win. So they are going to have things that looks like, the constant is probably going to be pretty low. There's no reason to believe it's going to be any specific value. Maybe the coefficient on my home variable is 0.05. Maybe, I don't know. What's another thing we could do? We could do kind of the current win percentage of the team increases, what they're probably winning the next game. Like all these different variables, and we could come up with this prediction. That's essentially what they're controlling for. So any variable that was used to come up with that probability of winning the game, essentially, if we include this now, this is kind of a weird thing, but if we include this probability of winning now, it's essentially like we could just write this whole thing out. We're controlling for everything that the sportsbook thinks matters. Not only are we controlling for everything that we think the sportsbook thinks matters, it's whatever weight they assign to those things, right? Or it's whatever coefficient they came up with. So now if we include additional things, like let's say, now in this regression, I'm going to say, okay, was the team the home team or not? Well, I've already got what the sportsbook think, how much the sportsbook think that should matter, kind of baked in here. I'm controlling for that. So if I find any additional effect here, anything other than 0, that's telling me how far off, right, those sports books are. Because now I'm looking at the actual game and whether or not they won. And if they were the home team, if let's say this is 0.02, well, that's saying the sports books are actually not increasing the probability as much as they should be. They should not only be increasing it by 0.05 in terms of the predicted probability of winning, they should be increasing it by a little bit more, right? So if I was a bettor, I might look at this and say, okay, look, that means that most of these home teams are going to have the line set a little bit too low, or they're going to have the probability of winning be lower than what it should be. So controlling for that probability, we're going to get hopefully some kind of interesting results. What they then said, okay, look, we've controlled for this, and they thought kind of an interesting thing to do was look at, okay, maybe like being the home team, why might there be an advantage of being the home team? That's really the explanation that's kind of generally given, right? It's that there's something about maybe the comfortability of the arena, right? You're in your hometown, but also the fans are more often than not behind you, right? So they said, okay, look, maybe there's an impact from being the home team that they're not factoring in, right? They're not factoring into these lines. They then use these things called ghost games. So over COVID, there was games that were played with 0 fans. Right? This is the idea of a ghost game. The game is played, but there's no attendance. Right? There's no one to cheer for that home team. They then kind of took this idea of whether or not they were a home team, and this time variable was how far away from that initial date where they didn't allow fans was this game being played. Right? So maybe there was an impact of being the home team, but the further out we get from this ban, right, maybe it matters less, right? Because there's not as, we don't have as many people in the stadium. So, and then also maybe during these ghost games, we saw a different effect. So let's scroll down here, and they use some bookmakers, but also a betting exchange. Let's look at the betting exchange. I just believe the data a little bit more. So they've got this probability accounted for already. And if the sportsbook are doing a good job, then yeah, their predicted probability of winning should be a really good predictor of whether the team actually won. Sure enough, the effect is positive and significant across every single type of kind of regression they ran. And they did like some different controls in some of these different columns. We'll just kind of look at column 1. They're all pretty similar. What's interesting is if we look at that home variable, well, it is positive. Maybe the sportsbook aren't kind of quite capturing the correct, but we can't say that that's any different from 0. We don't have any statistical significance. When it comes to accounting for the fact that how is being a home team influencing the probability of winning, sportsbooks are doing pretty good. We can't say that there's any effect they're not capturing. But if we look at these ghost games, the sportsbooks were really bad at predicting. Now, why were they probably really bad? They didn't have any old data, right? There were like previous ghost games, and so they might have tried to come up with some proxies to come up with a prediction, but they weren't doing a very good job. So here you can see that how much should a ghost game actually increase the predicted probability that a team wins? Well, it was actually 0.1. Right? But then this is kind of weird because, well, if it's a ghost game, if there aren't fans, shouldn't that actually decrease the well, it's only going to decrease the probability you win as opposed to before if you're the home team, right? So here, if I'm the home team, we include this interaction term, and it's a ghost game, it decreases the probability that I win that game. And in fact, not only is it decreasing it, the exchanges weren't accounting for that, right? The exchanges weren't decreasing the probability that the team would win by as much as they should be. And then this would capture the effect that, oh, for the away teams, they were more likely to win, or the sports books weren't capturing as much of the fact that they were more likely to win during a ghost game, which would make sense. If you're the away game playing at, and there's no crowd, well, now my chances of winning go up. So it's kind of an interesting, like, natural experiment because, like, it's not like these teams coordinated when they didn't have fans or not. It was just the pandemic happened. Now we don't have fans, right? So it was this nice natural experiment where we can see that kind of the effect of this kind of home game. They weren't really, they know that fans matter, but sportsbooks weren't capturing it as much as it matters. Any questions on this idea? It's kind of interesting result. And I think they find similar things if they use like bookmakers. Yeah, so they still found a positive, negative effect. The magnitudes vary a little bit. I also thought they had some kind of interesting graphs. So this May 15th was the date they used when there was like these ghost games starting. So you kind of see like initially, everyone generally tends to bet more on the home team. But what are your returns if you did? Well, initially, started losing a little bit of money. Now these ghost games really start kicking in. People betting on the home team because there's that huge decrease in the probability they win that was occurring. That was like negative 2.7, right? That was a pretty large in magnitude even. You see that like returns are all negative, right? In fact, look at the only people that have positive returns, it was only people betting on the away team, right? But then over time in this market, generally like everybody's returns ended up being negative kind of once they got far enough out. But I don't know, that's kind of an interesting result to show those negative returns were actually getting larger as these games were being played for people who bet in the home team versus the away team. They also tried to do some things where they looked at the time since those ghost games started occurring. I moved my cursor in front of this in accident. So here you can kind of see that interaction term. We still see a kind of similar effect from these ghost games versus these ghost games for the home team. They then interacted that home team variable with the time since these ghost games starting to occur. And what they found was this positive result, right? So that from when they started having these ghost games, as time went on, the home teams were starting to get more of a positive effect and canceling out the effect of that game, or they got more used to playing in these ghost games, right? As time from this very first ghost game occurred, went up, well, then being the home team, my probability of winning actually starts to increase a little bit. So this is kind of the story of when there was no fans initially, these home teams took a huge hit. They lost this kind of home field advantage that was occurring from having fans supporting you. Initially, they took that huge hit, but then over time, this is kind of telling us they were adjusting to not having fans, right? And that having these ghost games as a home team didn't decrease the probability that they were going to win as much, right? It was kind of being negated a little bit by how far out from that very first game that they were. Okay, so first of all, I'm not going to expect you to go through something near as detailed as this when it comes to the kind of questions I ask you on the exam. I just want to start thinking about like some of these larger questions that can be answered. And I thought this one was kind of an interesting one because one thing that we're doing with regressions is we've got some variable we're interested in, right? We run this regression and we obtain all these coefficients. So what can I do with that? I can come up with predictions for whatever that y variable was. So if I had all this win data and I had all this information on, was it a home team? What was their win percentage of the current game? What was the away team's win percentage? I could then take all those coefficients and start to make predictions for other games. I would know, like in this game that's going to be played today, is the team I'm looking at the home team? What's the win percentage of that team? What's the win percentage of the other team? I can use those coefficients, plug in these hypothetical X values, and come up with predictions for every single future game, right? If I can come up with these predictions for every single future game, maybe that allows me to think about, well, I know this team's more or less likely to win. So for instance, let's say I went through that process, right? I run this regression, I've got all these control variables. I then start coming up with, okay, whatever these coefficients are, I can come up with what the predicted probability in winning is. Sorry, I should have wrote probability here still. But as like I'm coming up with a prediction. I can plug in these hypothetical values. So maybe it's a home team. Maybe their win percentage is currently, I don't know, 65%. I go through all my control variables and plug in this hypothetical future game. Well, let's say I come up with a probability that they win is like 0.6, right? I then go out and I look at the current betting lines and it's even. Well, if it's currently like, when I say even, usually they don't do a 0-point game. They'll do something like half point, right? If I look at this, I'm like, well, if that's what they believe is a 50-50 bet, there's a 50% chance that they win by more than half a point. And I'm saying the probability they win is 60%. It's probably a good bet to take, right? Now, it's a little bit more complicated as we're thinking about when these lines are changing from like an even bet, but that's the general idea, right? We can use this old historical data, come up with predictions for this Y variable we're interested in, and then maybe look at what these sports bet companies are doing, and that would be kind of one strategy how you could maybe make money off of betting as opposed to what they want to occur, which is that play long enough, probably gonna lose money. Any questions? Yeah.
What all do you want us to represent from the paper?
So, and for your projects?
Yeah, like, do you want us to show the regression models or just a summary of?
Yeah, so if you're starting to think more about your projects, all I would like, if we're looking at these papers, the things I generally point out to you are what? So I don't want you to do anything near as complicated as what this paper did, but that first one we looked at, I really think is a good indicator. So go back up here. A nice thing to do is lay out what your regression you ran was, right? Now, sometimes like in that second paper, they had like Y is equal to, and then in the text, they said what Y was. I don't think that's probably the most efficient way to do it. I just want to see what was your dependent variable. You can tell me my dependent variable Y was this in the text, and then just write out the regression Y is equal to, and I think it's probably easier to just use the word, right? So betting value, right? That was our dependent variable here. Then just include all these other variables that you've included on that right-hand side as independent variables. So lay out that kind of regression equation. From there, I just want to see your results. So I want you to include, now these tables aren't going to look like the ones that come out of Excel, but I just want you to include whatever that regression output you get from Excel is. And then from there, when you're discussing kind of what these regression results tell you, you can go into more depth. But kind of the minimum of what I'm expecting is, for instance, if I'm interested in specifically, like I should have a general question, right? So if I'm interested in specifically, how does being the home team impact the probability of winning? Then you need to make sure you give me an interpretation for that variable's coefficient, right? You don't have to give me an interpretation for every single control variable you used. And then if you're running this for like the probability of winning for home teams, and you are interested in something like how does that vary, excuse me, with these ghost games? Well, if that's part of your question, then yeah, you should probably interpret this, and I should wrote this as B, there we go, different, and interpret that, right? But at the very least, kind of interpreting that main variable of interest that you have. And we'll kind of keep talking more as the week goes on, but like, you should also be making some reference of, is it statistically significant, right? At what levels can you say that there's actually that this effect actually occurs, right? Because if our p-value is not less than alpha, we can't actually say that impact is anything other than 0. And a lot of your data, you're not gonna have the most extensive of controls, right? And so it may not be that you can say this at statistically significant levels. That doesn't mean you shouldn't still interpret kind of the results that you found. For instance, Jesus. So if we go back to the sport betting volume one, right? If I used NHL data, maybe I think that playing games on network television doesn't matter, right? But it's probably because my guess would be the data set wasn't as large. Maybe it was. Maybe there's other things. NHL is not as popular of a sport, and so maybe you get less casuals who are betting on this sport. So we come down here and we're like, we didn't find an effect, but we only had an R squared of 0.17, right? It's probably a lot of other control variables that we would have loved to have in this regression. But just because we didn't find an effect here, if we looked at those network coefficients, well, CBC or CBC, TSN still having these games up, there was some positive effect, right? And in fact, if we had NHL represented on larger networks, if we look at the NHL results, we say, well, it doesn't matter. People don't bet more on games that are on network TV. Well, but yeah, a different sport, if we had kind of more variation in the networks they were on, maybe we actually do find an effect. So just because you don't find it to be statistically significant, the sign and the magnitude still kind of matter, right? And we can still interpret what the sign and the magnitude of that coefficient is telling us about our predicted Y variable. Okay. Is that making sense? Any questions on that? Yeah, a minute or two. I'll also harp on one more thing, and you don't have to go through and compute exactly what the p-value is, but I would also, if you're looking at the regression output from Excel and it's giving you like the test statistic or the p-value, let's say I get like 0.11 as my p-value. Is that going to be less than my alpha of 0.1? No. So I can't say that the variable would have any effect at the 90% level. But Jesus, I could say it at the 89% level, or, it's not that far away. So just because you don't find it to be significant, I mean, if that p-value is anything less than 0.2, you're above 80% confidence. I mean, I say a lot of things in my daily life without 80% confidence, right? So, I mean, this is not bad. So don't just say that it's not statistically significant. Look at that p-value and actually say, if it's close, if it's not, okay? All right, glad I made a couple of you laugh, right? So we'll kind of end it there today. If you have more questions on your project, like from here to the end of the class, I'm going to be bringing in probably a lot more articles that I think are interesting. Expect questions from you. If you guys have some questions about the projects or working with the data, feel free to bring those to class. We can kind of troubleshoot and work on some of this stuff as we go. Other than that, I might also do some review of some older models and things that we've talked about, things that I'm noticing when I graded the homework or on the following homework. So hopefully it'll be kind of pretty interesting. If you guys have anything you're interested in too, feel free to email me. I'll try to find an article to bring to class about it. Other than that, because you guys all showed up, I want to give you points for showing up here today. Make sure you just get a response in on your way out. Other than that, also have office hours. If you have any questions, feel free to stop by, and I will see you guys on Wednesday.
On Wednesday.
Yep.
Okay.
Yeah, I'll be there 2 to 4 days. Well, yeah, 2 to 4 Wednesday and Thursday as well.
I'll be there.
And if it doesn't work, I'll be here longer. So if it doesn't work, we can set it up.
Okay. So I've been using R, and I tried using R Studio, and then I tried using just the regular R program.
Yeah.
And then for some reason on Studio as well, so now it's allowing me to download packages, but if I go into the regular R, which is just a terminal, it'll let me download stuff. But if I try and open an R Markdown or something.
Yeah.
So we have. My professor for the other classes. Miss in that way, but she's foreign and doesn't quite understand what I'm asking.
So
I thought maybe
R Studio, you try to install package and then use package.
Well, it doesn't even install it. runs through, like, you know, how it goes to, it shows it's going to a website to retrieve it or something.
Yeah,
It goes through a massive list just for one package and
Oh.
then fails to.
so
download it.
here's an issue. Is this your first time using R or have you?
I've been
used it in
using
the
it a
past?
couple times.
Okay,
But just this.
so I've done the same thing and I honestly, I still am not 100% clear exactly, I am, but
Yeah.
this is kind of what's going on. So if you install packages twice, so once you install it, it's there.
Right,
So from then, whenever you start a new project, you can just go like use package.
yeah,
If you install it again, for some reason, it can like screw it with it and then you can't use it.
oh, okay,
I don't have a solution other than I just re-downloaded our studio
yeah.
and then installed it and made sure I kept track of like, I've already installed this, and then just use package for me. Does that make sense?
Yeah, but like in our studio, you have a packages window, you can look through the whole list of packages
Mhm.
I've downloaded. I'll do that, or like I'll download a package and then look at that.
You can
list.
see it.
It doesn't
Doesn't show up.
Like it completely
Oh,
failed to
never
download.
mind.
And cause on,
How would that be?
just a regular R terminal. it can use
Are you-
the-
The only other thing I can think about is, are you making sure that you have a Wi-Fi connection at the time?
Yeah, I'm on Ethernet desktop.
Um,